to work out this question, I'm going to use two methods. Now, method one, I'll just use the long method. So A multiplied by A multiplied by A divide by A multiplied by A multiplied by A multiplied by A multiplied by A, and I'm multiplying A by itself 7 times. So 1, 2, 3, 4, 5, 6, 7. Now, obviously, you know that if I divide A by A, I get 1 because I'm dividing that by itself. It's just the same as dividing 2 by 2. I get 1. So if we know that, we can simplify this expression. But we know that if we divide A by A, we get 1. So that's gone. A by A, we get 1. That's gone. A by A, we get 1. That's gone. So what will remain with here is 1, the numerator, over A by A by A by A. So 4s in the denominator. Now we can write that in power form, so or as an index. So we end up with 1 over A to the power 4. Second method. So method 2. Now, you remember when we looked at division of indices, when you divide indices, you subtract the powers. So what I'm going to end up with here, if I'm to simplify A to the power 3 divided by A to the power 7, that will be equal to A to the power 3 minus 7, which is A to the power negative 4. Now this is interesting. We have one question but two answers. We have this answer and this answer meaning the same thing. So we can say that if these two answers mean the same thing, because we actually came up with these two answers from the same question, we can then say, or we can summarize and say that 1 over A to the power 4 is equals to A to the power negative 4. That's a very important result. One question, two answers. So these two answers must be the same because you're actually coming up from the same question. So the question here is, what does this result here mean? 1 over A to the power 4 is equals to A to the power negative 4. I'll explain that below here. So if I have, so I'll draw that. So if I have 2 to the power negative 4, for example, that would be 1 over 2 to the power 4. And 1 over 2 to the power 4 basically means that I'm going to divide 1 by 2 4 times. I repeat that again. 1 over 2 to the power 4 means that I'm going to divide 1 by 2 4 times. So that means that I'll end up with 1 divided by 2 divided by 2 divided by 2 divided by 2. So that's the meaning of that. Another example, if I have 3 to the power negative 5, that is the same as from our results there, our conclusion up there. This is the same as 1 over 3 to the power 5, which will be equal to 1 divided by 3 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 5 times. So 1, 2, 3, 4, 5. And that will be the result of 3 to the power negative 5. So we can conclude here and say that, just create more space here. So we can conclude and say that a negative exponent means how many times to divide 1 by that number. So a negative exponent write that clearly. So a negative exponent means how many times to divide 1 by that number. And I've already illustrated that in the 2 examples that I've given above here. So that's a very important result. And this is what negative exponents are about. I mean, if you have, for example, 3 to the power negative 7, that means 1 over 3 to the power 7. So that means we're going to divide 1 by 3 7 times. Just as simple as that. Okay, so we'll move on to the next page and look at some examples here. The first example is we write these expressions using fractions. So just using the same formula that we have derived in the previous page, that we have observed, that we have observed from the previous page, we can simplify these expressions. So a to the power negative 2 will be 1 over a to the power 2. This will be 1 over b to the power 4, 1 over 3 to the power 4, 1 over d to the power 5, 1 over 7 to the power 8. Now, some of these answers you can simplify. For example, 1 over 3 to the power 4, if you use your calculator, you'll end up with 1 over 81. I'll show you that. So if you go on your calculator, if it's on, just press 3 to the power of 4, enter, you'll be able to get that 1 over 81. Likewise, if you have 7 to the power of 8, so if you go 7 to the power of 8, you'll be able to get that. So we'll just write these answers because we can actually work that out. Remember, in your exams, you're allowed to use calculators, so we can go ahead and write these answers. So this will be 1 over 5764801, and this is 1 over 81. Okay, I'll move to the next example. We write these expressions without fractions. So here we are writing without fractions. What that means is we are going to use negative indices or negative powers. So this will be p to the power negative 3, 5 to the power negative 2, r to the power negative 4, s to the power negative 7, and t. Now this is, if you have t just on its own, that means t to the power 1. And what that means is you're multiplying t by itself. Of course, if you multiply t by itself, no, you're not multiplying by t by itself. You just have t, so that's just t to the power 1. So what you'll end up with is just t to the power negative 1. When you bring it up, you're going to have t to the power negative 1. So t to the power 1, remember, means that you just have the number itself. You have the number in itself. So t to the power 1, the number, you just have the number itself. Good. I'll move to the next questions. These are extra examples just to help us understand this concept. Now, rewrite these expressions using fractions. So, 3 to the power negative, remember what we said? If you have something like a to the power negative n is equals to 1 over a to the power n, we're just using that formula. So here, 3 to the power negative 4 is same as 1 over 3 to the power 4. You can simplify that using your calculator. I showed you how to do that. 1 over 81. 2 to the power negative 6, 1 over 2 to the power 6, and 2 to the power 6 is 64, so 1 over 64. Again, you can use your calculator. That will just be 1 over 7 to the power 1, which is same as 1 over 7. This will be 5 to the power 1 over 5 to the power 2, which is 1 over 25. This will be 1 over 10 to the power 7. So you'll end up with a long answer here. 1, 2, 3, 4, 5, 6, 7. These are zeros. Let me write that properly. So 1 over 1, 2, 3, 4, 5, 6, 7. Good. So that's how you use the idea of negative indices to work out this kind of questions. So I'll move on to something else here that I want to explain. Now, to raise a fraction to a negative power, use the equivalent positive power and then interchange the top and the bottom. Now, I'll try to explain here if you can get why. So, a over b to the power negative n is equal to 1 over a over b to the power n, and this is equal to 1 over a to the power n over b to the power n. Now, if you remember your knowledge on the division of exponents, this is the same as 1 divided by a to the power n over b to the power n. This knowledge on division of fractions. That's what I meant. So if you remember knowledge on division of fractions, 1 divided by that is same as this, what I have in green. Now, if you divide a fraction, what do you do to the last fraction? If you divide fractions, you get the reciprocal of the last fraction and change the division to the multiplication. So what we end up with here is 1 multiplied by b to the power n over a to the power n, which is the same as b over a to the power n. Now, I know some of you may be lost in this process, but what I want you to do is don't panic, because no one will ask you to rewrite everything that I've written here, trying to explain here. What you're required to know is just that if you have this, a over b to the power negative n, that will be equal to that. Okay? So basically, if you have a fraction to a negative power, what you need to do is use the equivalent of the positive power, and then interchange the top and the bottom. So here, our power is n, right? Of course, it's negative n on the left. So what you're doing is you're ignoring the negative and just using n here on the right. But now look at what you're doing on the fraction a over b. We interchange the top and the bottom to end up with b over a. So in short, what you're saying is this. This is the most important thing that you need to know. So a over b to the power negative n is equals to b over a to the power n. This is the most important thing that you need to remember. So if you can't follow through the process that I've used here to explain what's happening, all you need to know is just that, because this is what you're going to apply to solve a couple of problems here. Okay, so let me start by working out these questions here. Now here, remember what we said is we are going to use our positive exponent, so basically, and then we get the reciprocal of this fraction. Okay, use the equivalent of the positive power and then interchange the top and the bottom. So if we interchange this, we're going to end up with 2 over 1, and then you just ignore the negative. So that will be our answer. And then you can simplify that, of course. 2 divided by 1 is 2, and 2 to the power 1 is just 2, so the answer will be 2. Here we'll do the same thing. Get the reciprocal of 1 over 4, which is 4 over 1. And then ignore the negative and just write the power there. So what you end up with 4, just 4, because 4 divided by 1 is 4, and 4 to the power 1 is just 4. That's your answer. Here we're going to do the same thing. Interchange the top and the bottom, so 3 over 2. And then ignore the negative and just write the power. Now this is equal to 3 to the power 2 over 2 to the power 2, which will be equal to 9 over 4. And then in the last question, you'll have interchange the top and the bottom, so you have 4 over 3, ignore the negative, to the power 3, which will be equal to 4 to the power 3 over 3 to the power 3. And the thing here is, it's everything to the power 3, everything in the bracket to the power 3. So 4 over 3 over 3 to the power 3, and then you can work that out, which will be, you can use your calculator, so that will be 64 over 27, 9 over 27. So that's how you use that formula to simplify expressions like this ones. I'll move on to, that's the last one. So that's how you use this formula to simplify negative indices, and that's it.